Today's lesson is going to focus on nitrogen-based organic molecules called amines and amides. Now that we're dealing with nitrogen-based organic molecules, we're going to talk about each one separately. Amines will contain nitrogen, obviously, but they are also basic. So now we're dealing with amines and amides that with this nitrogen, they're actually derivatives of the ammonia molecule. And ammonia is very basic, and so are amines and amides. With our structure right here, with nitrogen, remember that nitrogen has 5 valence electrons, and out of those 5 valence electrons, 2 of those electrons are paired. So it's not in this structure, but you should remember that there is a pair of electrons there. And that is important when we talk about polarity. Okay, so it may cause the amine molecule to become polar. The amine molecule will have at least one R group, and sometimes these hydrogens will also be R groups as well, but sometimes they could be hydrogens. And that will change the classification to either primary, secondary, or tertiary amine. What we see right here, this would be a primary amine, because there's only one R group. If the nitrogen was bonded to 2 R groups, it would be a secondary amine, and a tertiary would have 3 R groups. As you already mentioned, they are basic, so their pH is greater than 7, and they have really strong odors, okay? And the odors are not good, all right? So they don't smell very good. Amines are actually produced from the flesh of like decaying fish. So when you smell like a strong fishy smell, that's usually an indication that the fish has been around for a little bit, and bacteria are decaying the flesh, and they release these amine compounds that have a foul odor. They are also part of amino acids, so you will see them in biochemistry. Naming amines and amides is a little bit different than normal organic nomenclature. So with an amine, you are going to find the parent alkane as the longest carbon chain attached to the nitrogen. So we're going to come down to this example right here, and there's my amine group, and this is the longest parent chain attached to the nitrogen right there. We're going to number this parent chain from the side closest to the amine group. So I'm going to number it from here, 1, 2, 3, 4, and 5. There is nothing attached to the nitrogen, so there's no other R groups. So we're just going to say that the amine group is on carbon 2 of a pentane, and then we're going to add the suffix amine. So we would pronounce that 2-pentanamine. If we look at the next one, here's my nitrogen in the middle, and this is the longest R group or parent group attached to it. So then right here, this shorter chain is a methyl group, as we know. And what we'll do is, with the second step here, it says branches are identified and named as usual. Any branches attached to the nitrogen are given the letter N as the locant. Okay, so what this means is that we're not numbering the other side of the nitrogen. We're just saying that attached to this nitrogen, I have a methyl group. And so we name it like this, N-methyl, and that's a dash. And then the parent that is left over is a 2-carbon ethanamine, and the nitrogen is on carbon 1. So you could say 1-ethanamine if you wanted to, but you don't have to here, because with a 2-carbon parent, it can only be on carbon 1. Let's look at this last example. So again, there's my nitrogen in the middle. I want to find the longest carbon chain that is attached to it. So again, I'm going to be talking about an ethanamine. And then any branches, so there's a branch on the one nitrogen, and then there's another methyl. And so when we name this, we're going to say on the N, and again on the N, I have 2 methyl groups. So I have dimethyl, and then we're left with ethanamine. So it is a little bit different, where we're just stating the branches on the nitrogen. You could have branches on the parent chain as well, and if so, you would give them a position number. But any branches attached to the remaining nitrogen spots, we use the letter N. The other nitrogen-based family are called amides. And amides are amine derivatives, so we just saw that family, of carboxylic acids. So they're actually a blend, amides, of an amine and a carboxylic acid, and they are created much like an ester is created. So compared to amines, amides are very weak bases, so their pH values would typically be a little bit closer to neutrality than an amine would, but they still are basic compounds. The amide linkage is often referred to as a peptide linkage in biology world. Okay, so we don't tend to call it that in a chemistry class, but in the bio class, you maybe have heard of the term peptide linkage. And this is a main component of proteins. Okay, so amides are a main component of proteins. Here is the amide linkage right there. Okay, so you have your carbonyl that's coming from the carboxylic acid. You have your nitrogen that is coming from the amine. And then depending on what's attached, you might have, so these R groups might be carbons, they might be hydrogens. Okay, it all just sort of depends on what was bonded to them. And we'll create an amide through a condensation reaction. Because we now are dealing with an amide, so right here, I'm going to block out my amide right there. I now have dipoles that can run through the carbonyl. And I also, depending on your molecule, you might have a dipole running through the nitrogen as well. And you might have hydrogen bonding. So depending on whether those nitrogens are bonded to hydrogens, which they would be if it was a primary or secondary amine, you might set up hydrogen bonding. You cannot, okay, so not with a tertiary, because a tertiary amine has no hydrogens on it, which means you would not set up hydrogen bonding. So anyways, if you can set up a hydrogen bond and the extra dipole, it just means that the amides have pretty strong forces of attraction for themselves. And to water. When we name amides, they're similar to naming an ester, where with an ester, you need to locate, sort of like break the ester bond, or in this case now the amide bond. Whatever is attached to the carbonyl, we name as the parent. Okay, so the root name is based on the longest chain that includes the carbonyl, and then the amide suffix is used. And then we look at our nitrogen and we use those same rules as an amine. So whatever is attached to the nitrogen, we would state that branch and use the letter N. So in this first example right here, I have a methyl attached to the nitrogen. So I'm going to say N-methyl. And then my parent is a 2-carbon amide. And there are no branches there. So we're just going to call it ethane amide. So we use amide as the suffix. This little molecule right here is a very simple 1, 2, 3 carbon amide, and there's nothing attached to the nitrogen. So all we have to say here is we're going to call this a propane. It's all single bonded, and then we're just going to say amide. So propanamide for the name of that one. It's a nice simple one. Let's look at this third one. This is a little bit more complex. So again, you know, break your amide bond right there. Here is my parent, okay, a 3-carbon. And on carbon 2, I have a methyl right there. On my nitrogen, I have a methyl and I have an ethyl. So we still use the rules of alphabetical order. So I'm going to write it down here. So I'm going to say N-ethyl first. And then I'm going to group my methyls. Well, one of my methyls is on carbon 2 over here, and the other methyl is attached to the N. So I'm going to say N2 dimethyl, And now I'm done with my branches. I have a 3-carbon amide, so I'm going to call it propanamide. Amides can be created through a condensation reaction. So let's go through an example of this, and we'll just pick, here is a 3-carbon carboxylic acid. Put our hydrogens in over there. If we're going to bond this or react it with an amine, it has to be either a primary or a secondary amine. Okay, it won't work with a tertiary because you've got to pull out the water molecule. Okay, so you got to pull off a hydrogen off of that amine. So what I'll do is I'm going to do, let's do a primary amine. So we'll do here, methanamine. Okay. So my OH and my hydrogen are going to come off. I'm going to create water as a result. And then this carbonyl is going to just link right over to the nitrogen. So don't lose any of your carbons. So I had a 3-carbon carboxylic acid. That still remains. And then that's going to be bonded to my nitrogen and my methyl group. And I have still 1 hydrogen left below. Okay, so there's your condensation reaction, very similar to an ester, just with an amine instead of an alcohol. So as we've already alluded to a little bit, amines and amides, because of the nitrogen, can be a polar molecule. So they're going to have higher boiling points and melting points than their corresponding hydrocarbons because of the dipole. Small amines are soluble in water, but as the number of carbons in the chain increases, our solubility decreases. And we've seen that oftentimes because we get a larger non-polar section, the more carbons and hydrogens that we have. Nitrogen is more electronegative than carbon or hydrogen, so we're going to make our NH and our NC bonds polar. Okay, so there'll be a dipole there. But the thing is that the NH bonds are less polar than oxygen-hydrogen bonds. So when you're comparing an amine to an alcohol, for example, that has an oxygen in it, the amines dipoles will be weaker. Okay, they aren't as electronegative. And so your dipoles are just a little bit weaker. And here's a great example of this. Here is ethane, okay, and ethane's boiling point is -89. Here is methanamine, and his boiling point goes up to -6. When you add in here, there would be a hydrogen bond with that amine group right there. You'd definitely be setting up a hydrogen bond. But when you compare methanamine to methanol, there's quite a significant difference in boiling points, and that is all based on the fact that oxygen is more electronegative than nitrogen.